Hey guys, welcome to McFall Tech. Today we're going to be coding an ARM template live in VS Code. If you don't know what ARM is, ARM stands for Automatic Resource Management, and it is Microsoft Azure's infrastructure as code solution. It allows you to deploy multiple resources to the cloud all at one time using this declarative syntax, which makes it incredibly easy to just specify the infrastructure you want and then have it be created. Today we're going to go ahead and create one 22.04 Jammy Jellyfish instance, one network security group for that instance to allow me access, one public IP address for that instance, and then one network interface card for that instance. Join me.
Okay, so the first thing I'd recommend is to do this in VS Code and then to come over to the actual marketplace and grab a few extensions. Now what I like to use are what are listed right here, and that's the Azure Resource Manager tools, this first one. This is actually published by Microsoft and it's incredibly useful. This has predefined syntax for you to go ahead and quickly create resources and then just fill in the blanks. Very good tool. The next one is the Azure CLI tools. This is also created by Microsoft. It's not necessary if you're deploying directly with Azure CLI and something like a Windows subsystem for Linux, but I also think it's a good thing just to have on hand, although I'm not going to use it directly in this video. And the last one is the ARM template viewer. Now the ARM template viewer is great. This allows you to visually see your code and the relationship between the separate resources that you're creating. So it's an excellent thing to have. It's a good way once you're done writing a template to be able to visualize what is going to happen and what it's going to look like in Azure and the relationship between resources in Azure. For example, a network security group with the VM or a network interface card with the VM and all that good stuff. Okay, the next thing we're going to create the new JSON file, right? So I'm writing the directory I want to be on. I'm just going to touch the McFall Azure ARM JSON file is what I'm going to call it. And then from here we can just refresh in VS Code and you'll see the file created right there, and then we'll go ahead and open it. Now of course, when you're writing an ARM, if you're writing an ARM template directly, you're going to be doing it in JSON. If you're using Bicep, that's different. I'll discuss it in later videos once I've learned some more about it. Okay, so the first thing we're going to use is that extension I talked about, the ARM tools. And if you just type ARM bang or ARM exclamation mark, it'll go ahead and fill out the prerequisites for you, right? So that's the parameters, the functions, the variables, the outputs, and the resources. All ready to go. Excellent. Saves you some typing, and it kind of keeps your code neat and organized from the outset. Now we're going to remove functions and outputs as we're not going to need that in this video. But it's still good to just have that laid out for you directly via that extension, that Azure ARM tools extension. Incredibly useful. Okay, so first we're going to declare all of our parameters. Now parameters are something that are given to the deployment at runtime, and they can be therefore changed from template to template if you need to dynamically input certain data. One example that's put around for this kind of thing is that if you have one template for a testing environment and then one template for a production environment, you might have different parameters for each. Now the first one we're going to do here is the McFall Azure project parameter, which you're seeing me put right there. Now this is actually going to be used to create dynamic names for the variables section later on, and it's basically just going to be of type string. I've gone ahead and added some metadata for it to describe it, but it allows you to dynamically create variable names for other resources. For example, if you have a network interface card, which we're going to create later, we'll use the string from McFall Azure project and then append.nic at the end of it. You'll see me put that in later on. The next is we're going to have location. Now, location's interesting as many resources require a location to be specified in it. So the way we do this without having to type in the location every single time is to declare the location as a parameter, right, of type string right here, and then we're going to use a function as the default value type for that location. So if you don't specify anything, it'll default into this value, and we're going to call the resource group function called .location, which is just pulling the location of the resource group that's specified for this template, again at runtime, because you'll be specifying a resource group when you run this. Okay, the next thing we're going to do right here is called the admin username, and this is just going to be the super user for the Ubuntu 22.04 Jammy Jellyfish, and it is of type string as well. Does not need to be a secure string. We're not going to be using a password file for this. It's just literally going to be the username. Now the next portion is the SSH public key. So this is going to be the key we're going to use to connect to the instance once it's actually created. Again, it's a public key. There's no private information here, so I don't need to make a secure string for this either. And I'll go ahead and add some descriptions to it as well, just to describe what it is. Okay, the next thing we're going to have is the home public IP address. So this is the IP address of my current location. And since we're specifying a network security group, basically a firewall, I want to be able to put on the allow list of that firewall the public IP address of my current location so I can just SSH to it directly. And that's also of type string. All right, now we're going to go ahead and get into declaring variables. Now, variables are statically defined. Their values are not really changed at runtime. They are what they are when you declare them inside of the template. Now, you're going to see, as I was talking about earlier, we're going to use the concat function right here and call the parameter McFall Azure project of type string, which is what we're going to place in at runtime, and we'll name our network interface McFall Azure project, whatever I put into that string value, -nic. And that's a great way to just be able to kind of dynamically create values for your resources without having to declare them at runtime with, tons and tons and tons of parameters. And you'll see this a couple times in here. So public IP address name, same thing. We're going to use the concat function, and we're going to call the McFall Azure project parameter right there again, and then do -IP, as you can see right there. And then the network security group name, same thing as well. So this is going to call that same function, that concat function, for the McFall Azure project. And in this case, what we're going to do is call it, -nsg for network security group. Right here. Perfect. That .nsg. Okay. Okay. Next, we're going to go ahead and declare the VM name. Okay. And then same thing, we're going to concat that parameter value of McFall Azure project and then just do VM here. Next, we're going to do that same function again for our data disk name. So we're going to put a 1 terabyte data disk on our 22.04 Jammy Jellyfish instance, and we're going to follow that same naming logic here, where we have the concat function for our Azure project, and then just do -disk right there. Okay, so we're also going to just go ahead and really have just string variables as well here in this next section, or in this next area right below this SSH key path one, and those are just going to be static names that we don't have to pull any parameter data in as well. But we're also going to have this SSH key path parameter, which will have basically the location we're going to put our public key, which is the default location on Linux hosts, which is that, home, the username, in this case that's the input of parameter admin username, SSH, and then authorized keys. So this will allow me access with the private SSH key I have here on my workstation, and this is just go ahead and setting that up for me on the new instance, on that new VM as well. And again, we're going to use that concat function. We'll pre-pinned, so in front of that function, or in front of the value we're pulling from parameter, we're going to put home, and then the parameter value for admin username, which I'll provide at runtime, and then finally the last part of the path, that .ssh authorized keys. Okay, and then we have those strings I was talking about here, just strings, no functions being used to define them. That's the VM size, which is standard B2S, and then the actual resource group, the VNet name, the Azure McFall 00 resource group.vnet, and then the subnet name as well right there. Okay, so now we're going to go ahead and deploy our resources here in the resource section. And you're going to see the arm-nsg function, well, not a function, but the arm-nsg extension feature I called from that ARM tools extension I talked about at the beginning of this video is coming into play. It allows you to quickly define a type of resource and all of its parameters on the fly with default values, and then you can just come in and put in the values that you need to use for your specific template. So it's incredibly useful. It allows you to write, to author these templates much faster, as you can just kind of have the bones of the existing necessary structure of any given resource and all of its different parameters, API version, all that stuff you'd have to type out manually. That's handled for you much more efficiently if you use that ARM tools extension. Now we're going to name the network security rules themselves right here, or at least the one rule I'm going to have. Now I'm actually not going to reference my variable here. I'm just going to come back and name it like, McFall network security group or something like that. Just so it's, yeah, SSH allow. It's more descriptive of the inbound rule itself. That way it just doesn't, it allows you to actually know what's going on with it. It's a little more easy to understand. Now, the source address prefix, this is actually going to be for my parameter reference for the home IP address, the IP address of my current residence right now, so that I can just connect into the host as soon as they get spun up. And this is great because, by default, instances as they get spun up are open to the internet on 22, so using this method, I'm actually more secure as I deploy. Now next, you can see using the ARM template extension, you can just quickly reference an entire NIC resource, and it puts out most of everything you need for it already, and it's that kind of default setting. I am going to modify it here a little bit because I don't need everything that comes with it by default. It's still quicker to author resources using that ARM template extension, but sometimes you do need to switch them around for your own needs, so they're useful for you. So here I'm going to make this resource dependent upon other resources as they deploy. And it's an important note here to make is that ARM, the resource manager, as it gets deployed, as you deploy resources through it, it does it in parallel. So it can deploy multiple resources at the same time, which is incredibly effective, and it's useful for quickly spinning up environments, which is what it's designed to do. But if you have resources that are dependent upon each other, for example, when you spin up a VM and you've created a specific network interface for that VM, you want to make sure that ARM actually goes through and deploys the network interface card before it deploys the actual VM itself. Otherwise, it might try to do it in parallel and it'll fail because it'll deploy a VM before the NIC that goes with that VM exists. And that way, in order to correct for that, you actually do this depends on logic as a parameter or as a section in a resource deployment. So when a resource goes to be deployed in ARM, it doesn't fail because it doesn't have the required resources necessary for it to deploy itself. So for this example, I'm waiting for the public IP address to be present before I actually deploy the network interface card. I don't think that's actually strictly necessary, but I think it's good just to have it there in the first place. So the subnet, this is just going to be my default VNet name, and then the actual default subnet of that VNet. And there's a small mistake here that I'll correct, where it's actually specifying the VNet name twice as a variable versus doing the variable VNet and the variable default, or just the string default basically, which I've defined as a variable. Okay, and then moving along, we're doing the public IP address now. And same thing as before, using that ARM extension, it's quicker to author this resource, as that most of everything I need is already put there by default. I'm just going to specify the variable name for my public IP address, which I've statically defined, and then have the display name for the tag also have that public IP address name. So I am going to have Azure just allocate the IP address dynamically, and then just have a basic SKU as well. Okay, and then I believe we're just going to actually create the VM itself now, which is going to be the final resource in here. Unfortunately, the ARM extension for VM is so incredibly long with all the default parameters because there's just so much customization available for VMs that I'm going to just go ahead and author it directly, manually create out the resource, which is fine because there's just a lot more configurations in the storage profile and the operating system profile and the network profile that I don't actually want to use for this example. So I'll just create it all directly, which is not too bad if you know what you want for the resource itself. And I'm going to reference my VM name for my variable, and then for the location, again, this is that really useful parameter function where I just call the location parameter, which in turn is using a function on the resource group that determines the location of the resource group that can then just be passed as the location value for any given resource. And then back on that depends on logic. I'm making sure that the network interface card exists, the virtual network interface card, the NIC, exists before I go to deploy this virtual machine. Otherwise, the deployment will fail because it cannot deploy without all of its resources being present, right? It's just a critical aspect of that deployment for just the VM. Then I have my virtual machine name and the parameter for the administrative username, which I do pass at runtime. And of course, for Linux deployments, I never use, or you should never use either passwords, especially when we're open up to the internet. Even if I'm locking down access through the network security group, it's just best practice to not use password authentication, but instead to use SSH key. So you're always just locked down and much more secure. And part of this logic here is that I'm actually going to configure, as I've stated previously, that the VM will itself for the administrative user will be configured to allow my existing SSH key that I already have here locally to be able to SSH in directly by just updating the authorized keys file for the super user that gets created for this VM at runtime. So that's just one way. That, in addition to having the network security group locked down to my current home IP address where I'm at right now, is a great way to just be really secure in your deployment, or at least in access to your instances, to your VMs in the cloud right out of the gate. So for this VM, as I said at the beginning of the video, we are going to go ahead and have a data disk as well. So this will be the 22.04 Jammy Jellyfish for the canonical publisher, so the creators of Ubuntu, and I'll specify that here as well. So 22.04 LTS, or long-term support Gen 2, and then after this is declared, we're going to go ahead and configure the data disk as well, which will be a 1 terabyte data drive on the VM that'll be present on boot. And of course, the OS disk is just going to be the kind of the default from image. So I believe for this VM size, about 30 gigabytes is what the disk should be. Now, data disks are of type array. I think it's kind of obviously because you could have multiple disks. And the LUN, I'm assuming, is also just 0 index, so I'm at LUN 0 for my one data disk name instead of starting at LUN 1. But I am going to pass my variable for the disk name, and it's just going to be a locally redundant storage for just cost effectiveness, right? I don't need globally redundant storage for this, especially for an example, and it's going to be 1 terabyte in size, right there with the disk size gigabyte value. And we are going to go ahead and create now the network profile for the VM as well. which should be the final parameter of the VM, right? So you have the storage profile, the operating system profile, and then you have the network profile and the hardware profile for a VM. So we've specified all of the properties now except for the network. So last but not least, we're going to specify the network interface that we've created previously in the resources by referencing its resource ID. And then from there, we are actually good to deploy, and we've created all of the resources. Okay, and then here is that graphical viewer of the resources, which is an incredibly useful extension. This is that ARM viewer, so we've got one virtual machine, the network interface, the public IP address, and then the network security group. And it just shows you the relationship from each of those resources to each other. It's a great way to just double check your resources, see what they actually look like. And it's right there inside of VSCode. So it's great, very useful. I highly recommend getting that extension. And there we go. There it is one more time. And now we're ready to deploy. Okay, so this is the Azure CLI command for deploying. This is the AZ deployment group where you specify everything that we've created in this template. So specifically all the parameters, the administrative username, the SSH key path, or the public key I should say, and then the home IP address of my current residence, and then the actual project name that'll be used to dynamically create resources. That's that McFall Azure ARM, that final parameter right there. And then of course you just name the resource group that it's going to be deployed to, the name of the deployment, which is just a label for that deployment, and then the actual path to your template file, which is the JSON file you've created, the actual template itself. So that's just a local path in this example for that file on my Ubuntu Windows subsystem. And then from here, it will run and then give you the deployment status and a JSON output of all your various resources. And once it is spun up, we can go ahead and connect using that public IP address and then using the SSH key that we've specified at deployment time. Now you can view the deployment by going to your resource group and then clicking on deployments, and it'll show you all of the various resources that you have deployed. We are ready to SSH into the new Azure VM at this time. So because we've gone ahead and put in the public key of my SSH key that I'm using here locally, I'm able to connect in with no issues, in addition to putting in the allow list my current public IP address. I can get into this new instance right off the bat from an SSH client without having to console in and set up anything manually inside the Azure portal. So I'm going to specify the -i flag and then just the path of my private key here locally on my workstation, and I'm ready to go ahead and jump right in. And we're SSH'd in. So everything looks good. Obviously I'm able to connect, so that means that the SSH key is being accepted and the super user McFall Azure has been accepted. But let's go ahead and check that everything is as we expect on the host. So in addition to the SSH key, I should have a terabyte data disk, which I do right there, SDC, which I can go ahead and mount if I would want to. But it looks like everything is exactly as we wanted it for this Azure deployment. It's that 22.04 instance. I can connect in, my user is present, the key is accepted, and it's what we wanted in our deployment. So thank you so much for watching. If you have any questions or comments, please don't hesitate to leave them below, and I will talk to you guys next time. Thanks.